you'll realize that PhD will never be your best work. Your thesis is a training. Training cannot be your best work. Your best work starts after graduation. That is when you use the knowledge that you acquired in class, in that training, to now impact the world. The best way, as Dr. Yuya says, and I agree, to finish your PhD work easily is to be writing. If you commit yourself to writing, even if there are only 2 sentences or 1 daily, in 1 week you have 7 sentences. If there are 2 sentences, in 1 week you have 14 sentences. If there are 3 sentences, in 1 week you have 21 sentences. And by the time 1 month elapses, you realize how much work you have done. So, as a PhD student, a PhD candidate, whatever happens, when you commit to do your writing, whatever happens, come rain, come sunshine, whatever happens, if it is one sentence you commit to write daily, write it. Cry if you must, but at the end of the day, write that sentence. Then you'll realize that you're making some progress. Part of the reason, as Hussein and others will tell you who have read my book, which I recommended, other than the research that there is, and it's being told in a moving way, you'd see the strategies I adopted to make sure that I finished my PhD in record time. And that helped me when now COVID came, and I employed the same tactics in COVID research and produced, in COVID research alone, I think I published 11 papers, 12 papers. So your PhD catapults you to do more. I will one day do a seminar on research. I have seen a lot of topics that are floated. Yes, they're beautiful, but I've seen one serious gap. Let's take, for example, somebody, a wonderful PhD candidate, wants to write about revamping fishing on Lake Victoria. Tentatively, that's a topic, revamping fishing in Lake Victoria, revamping commercial fishing in Lake Victoria. And it is this person's original work. Then when this work is given to a qualified examiner, if that examiner is Shem, the first thing I will do is to take that topic I am supposed to examine and put it on Google. In a certain university, where we will not say here, I was given a thesis to examine. The course of my operating procedure, Before doing anything, I just put the thesis on the Google Scholar. I found papers that are very related. Then I decided to put it on Google. I found almost everything else except the name exactly in a Kenyatta University repository. I returned the manuscript. That would be a waste of my time. And I also pasted the links to the repository of KU, to that university. And I told them that to protect the integrity of this university is not to have your work in a repository that has been put in another repository elsewhere, in another university. The thing is, maybe this student did work very diligently. Maybe this student did not take time to look if somebody has done something in this area. Maybe it is just a question of the topic, but that can make you waste 4 years of work by just not doing due diligence, doing all the relevant searches. Anyway, today is not about research seminar. Today is about advanced quantitative techniques. Let me also agree with you that however late we finish this, we will still going to do R, because I want you to be in a position to analyze not only your data, but data in your work environment. And in this class, we had shared two data sets. One was for the very inaugural county governments, their health implementation, their health expenditure. And the other one was for COVID. So whatever we do, in every class, we must do data analysis using software. I had agreed with you that you're not coming out of this class to be a statistics lecturer or anybody. Statistics is supposed to help you facilitate your work. In 21st century, where there is AI and all the other analytical tools, it is wrong to teach formulas, things like that, and then that is what you set in exams. No. In today's world, many things had been done previously for you. You're supposed to just extend that knowledge or use it to do your work. So you will allow me to share my screen. We are going to talk about probability distribution. I don't know if anyone is in a position of seeing my screen.
Yes, Dr.
Okay. Let me stop sharing this. This one I want to share. That's this one. Okay. Okay. Let us talk about, we are still on probability. And I know that the probability is one day does not pass without we use the word probability, possibility, chances. People should not be scared when they see the word probability. When we talk about probability, we're giving you we are sharing the edifice on which the work we are doing stands. Once you do not have such principles at the back of your knowledge, you find it difficult to relate with the work. Just the same way, if somebody is in a law class, master's, PhD, or undergraduate, and without having heard about Magna Carta and the civil liberties, they miss the basis on which law stands. It's for that such reasons that we give backgrounds of everything we do, the fundamentals on that we stand. So when we talk about random variable, this is an outcome of an experiment. It's the numerical description of outcome of an experiment. Experiment here in statistics is not using burettes and those other things. It's as simple as tossing a coin. We have to get the head or the tail. That's our experiment. So it associates the possibility of experiment with the outcomes and present that in a numerical value. So when you use the word random, and then you realize it can either be discrete or continuous. When we say something is discrete, for example, now in quantitative, it means it has a finite or infinite distinct value. It's like 0 is distinct. 1 is also distinct. 2 is distinct. That is what we say discrete variable. An example I've given here, X number of cars arriving at Eastern Bypass Expressway toll station, number of patients, outpatient in Sagam Community Hospital in Siaya. They can be estimated in terms of, they can be counted in terms of numbers, 1 patient. 1 car past the expressway. That is discrete. For example, we want to separate this from the other ones. In an experiment where individuals in the sample space are asked to recall characters in TV program Tausi, one cannot assign a numerical value because there are 2 outcomes here, recall or not recall. That is still discrete. You either recall or you don't recall. I know some of us here watch Tausi, and you can recall some of those characters. The people who are not old enough to have watched Tausi may not recall. So that has 2 possibilities, but it is still discrete, just like the head and the tail in tossing a coin. Recall, and not recall. So we can describe such an experiment of recall and not recall. We assign a value like 0, cannot recall. 1 can recall. So when a random variable takes many values between point A and point B, we say it is continuous. One example, if in a class we asked everybody to stand up and measure their heights, you'll find if it is in feet or in meters, let's say somebody is 1.2 meters, which is a very short person, very. Between 1.5 to 1.6 meters, there are too many numbers there. Too many. 1.5, 1, 1.5, 1, they are too many. Even in temperature, between 36 and 37 degrees Celsius, there are too many values. 36.001, 36.1. By the time you get to 37, there are too many values there between. That's numerous values between 2 intervals is what we call asymptotic property. For example, between 1 and 2, there are asymptotically many values. 1.1, 1.2, 1.1112. By the time you get to 2, the numbers are too many to even imagine. So asymptotic property is a property of continuous variable. slowly getting into where we can do some little calculations. I had a friend of mine joke that the last time she or he understood mathematics, algebra had not been involved. That the moment immediately algebra was involved, he or she stopped understanding mathematics. But here, don't be scared. Mathematics is a language of God. These symbols are easy to interpret. So when we want to talk about probability of finding a certain value x in a distribution or in an interval, we are talking about what we call probability distribution. Oh, I had also shared these notes in the e-learning platform. Somebody can interact with them later or at their own free time. In the learning platform, there are these notes. A discrete random variable x, the probability distribution is defined by the function p into x, where x is in a bracket. Now, probability of the value x written as sin. Now, if you are tossing a coin, there are only two probabilities. Either get a head or a tail. The probability of getting a head is 0.5, a half. The probability of getting a tail is also 0.5, a half. Now, the overall probability of getting a head and a tail is what we call summation. The symbol you see that looks like an inverted E or 3 is called summation. You are summing them together. If you sum the probability of getting a head plus the probability of getting a tail, it is 1, 0.5 and 0.5. These are still very simple to understand. Now, to understand probability distribution, let's take it as GIGI Motors or KDG Motors in Nairobi. They want to sell cars for 300 days, 65 less over here. Then they look at the cars they have sold in 54 days, the cars they have sold in 117 days, and the cars they have sold in any other day, and express that into distribution. If they say that GG Motors data shows that 54 out of 300 days, no car has been sold. The probability distribution of that period is 54 over 300, which comes to 0.118. No car has been sold in that probability distribution. Now, in 117 days out of those 300 days, one car was sold. So 117 over 300 gives you 0.39. Within that space, that distribution of days, only one car has been sold. And if you given that within a distribution of 0.24 probability, 3 cars has been sold, you multiply that probability with 300, you realize that those are what, 72 days. 3 cars were sold. This is just telling you how we can convert the sales of our cars and within the distribution of days. It is just jogging the mind. They are not asking you to calculate the distribution of those cars. That's just explaining the distribution. But somewhere along the way, we are going to calculate something. There is something we call binomial. Yes, please go ahead.
If I can take you back to the distribution.
Yes, please.
I think for me, it's not quite clear how you got 0.24, 0.04, and 0.01, or it's just random. I don't know.
Okay, where is that whiteboard? Let me get this. So we have okay. When I use another object, it doesn't write. If I use it writes. So we found that within a distribution for below 0.24, they sold 3 cars. Now, it was X over 300 that gave us 0.24. Now, if you want to know X is the number of days, see, if you see any number hanging like that, it means it's over 1. So if you cross multiply, X times 1 is just X equal to 300 times 24, those are 72 days. So within 72 days, they had sold 3 cars. I am looking for the rubber here.
Sorry, but how does 300 times 24 become 72?
No. 300 times 0.24. There's a 0 point here.
Oh, thanks.
Yeah, there's 0 point there. So it's interesting how probability works. We will not leave a statistics class without calculation. That is one of them. Now, when you talk about binomial experiment, in fact, by the name itself, nominal bi, means there are only two. So we're talking about a probability distribution where there are only two outcomes in every experiment that you do, whether it's tossing a coin, it has two outcomes. And each outcome is assigned either pi or 1 minus pi, but the total distribution, the total possibility is 1. So let's take our favorite example of tossing a coin, where the probability of success is pi, and the probability of failure is 1 minus pi, because what happens is that probability has always to be 1. The total probability has always to be 1. I might also go ahead to explain that the pi that people talk about, mathematicians talk about every day. This is a digression. It's just a story about pi. Pi never ends. It is 3.14. But if you continue calculating, it goes up to infinity. The last time somebody tried to calculate pi using a computer, it reached decimals of 1.2 trillions. They never reached the end. So people abbreviated it as 22/7. Now you have a calculator there in front of you. Can you try to divide 22 by 7? (22 divided by 7). You're seeing the value 3.142857143. The distribution of those numbers take no particular order, those decimals after 3. And they never end. Now, mathematicians have been trying to reach the end of those decimals. Up to now, they haven't found. They've reached 1.2 trillion and they are not yet found. So somebody went to the hospital and they had an headache. Now in that headache, the doctor asked him or her that, how intense is your pain? In a scale of 1 to 10, how bad is your pain? He said pi. The joke is that pi is not very painful, it's 3.14, but it's continuous, it's not ending. So it is a mathematical joke. People say if something is mild, but it's just continuing. So they say, the scale of 1 to 10, it is pi. It's continuous, but it's just, it's mild, but always continuing. That's a background of pi. Even if you Google at your free time, the symbol pi, how many people, the last calculation on pi, the number of digits after the decimal, you will be surprised. But in this case, we are talking of a different pi as a Greek symbol, we've assigned it a value of 0.5. When you toss a coin, the probability of head is 0.5. Probability of getting a tail is also 0.5. So if the probability of success is pi, then the probability of failure is 1 minus pi. So if we are given a situation where we want to know the number of times you toss a coin and probability of getting, let's say, 4 heads in 5 tosses, this might look far-fetched, but have you wondered if you have a goat and I am saying you are a female goat. I don't like the way they call the female goat. So this female goat can only give birth to 1 kid. I know the young one of goats are kids, they're not puppies. So can only give birth to 1 kid at a time. Then you want to, when a female goat gives birth to a female kid, in terms of demographics, that is something good. Because when we calculate fertility rate, which in other some other advanced demographics is the ability for a woman to replace herself. If in today's world, let's say, for example, in Kenya, women give birth to only male children for a period of, let's say, 10 years, the population will decline. If women in the childbearing age, that's 15 to 49, for a period of 10 years, give birth to only male children, the population will decline. Because a male child will never give birth, however hard they try, at least according to Robert Mugabe and according to nature. Now, that's why population and fertility are related, are taken very seriously. But if they gave birth to all women in the childbearing age, give birth to 1 child, 1 girl, they've already replaced themselves, because 1 girl can, in future, can give birth to 7 more children like that. So that is why the population of a country is tied to the fertility of women in the childbearing age. If you interfere with that fertility, you've affected the population in a future time, not today. Now you understand why anytime people are doing population studies, they calculate fertility rates. And fertility, in this case, we're only talking about fertility of women in the childbearing age. In this case, I'm giving an example of a female goat. The probability, you want to know the probability that this female goat will give birth every time it gives birth in the next five births. Let's say births are events, 5 births. It will give you 4 female kids. You want to find that distribution, that possibility, the possibility that this goat I bought is going to give me 4 kids in 5 occasions of birth. That's a function of binomial distribution. So if we give an example, even if we change that a fair coin to a goat, that a goat gives birth 5 times. And every time it gives birth, an observation is made, whether it's female or male kid. The following observations are made. The experiment includes 5 trials, where trials are 5 occasions of giving birth event. So when the goat gives birth to a female kid, that is success. A male, that is failure. Then the probability of a female kid, symbolized by pi, is 0.5. The probability of giving to a male kid is symbolized by 1 minus pi, is also 0.5. Find probability that in 5 trials they will get 4 female kids. So it is a case of 4 combination, a 5 combination 4. The probability distribution of 4 females in 5 cases, events of giving birth. That is the probability distribution. But now to get the probability itself, we have this very beautiful formula. Let me go again to whiteboard and see how we calculate that a goat giving birth 5 times will give birth to 4 female kids and 1 male. It is designed that way it is designed that way a whiteboard. Yeah, the rubber is here. So we are talking about probability of X. Let's say probability of getting 4 female children when a woman gives birth 5 times. 5 combination, 4 combination 5. So, sorry, let me first write the formula before I calculate it. Before we calculate it. Some of these things we're calculating in, most of these things we're calculating in probability are real life situations where a farmer has, so P probability of X, let's say that X is 4, is given by N combination X pi superscript X, first X. When you see a dot, that means there's a multiplication mark, by into bracket 1 minus pi N, N minus X. Something is disturbing me here. So this is N minus X. So once you get this, it's not very coming out very clearly. So let me see. Once you get that, you're in a position to calculate. So P probability of X equals to N combination X, the bracket, pi X times 1 minus pi N minus X. Now, that formula should not scare you. Now, we want to calculate the probability that your daughter-in-law, we make an assumption that we'll give birth 5 times. But we want the probability that those 4 of those 5 births will be female children, the possibility, the probability of that. So we make our PX, the X here before. So that we can write it as P4, therefore equals to, in 5 births, 5 combination 4 times our pi, the probability was 0.5, 0.5 power 4, our x is 4, times 1 minus pi, pi was 0.5, 1 minus 0.5 is 0.5 times 0.5 n minus x, 5 minus 4, 5 minus 4, which equals to 1. So you have your calculator there. 5 combination, and your calculator, there's a place for NCR, that is N combination R. So you say 5 combination 4 times 0.5 power 4 times 0.5 power 1. The answer equals to, I've got it on my side. Already you forgot your calculators when coming to this class. We will use calculators until the end. Again, this is just to show you the background of the calculations, the edifice on which statistics stand, or qualitative stand. So there's a 0.156. Now, that is the probability that if you have a female goat, under the assumption that the goat is not giving birth to twins, to twin kids, that female goat will give birth 5 times, 4 of which will be other female kids. You get that probability. So P for probability of getting those 4 kids is given by this one. This is equally the probability that if your daughter-in-law comes to your compound and they start giving birth, the probability that they'll give birth to 4 female kids in 5 attempts, in 5 events where events are giving birth, is still this one, 0.01. So it means the probability of getting 1 female is higher. 1 female, 1 boy is higher. So you can calculate that, you can jog with that along the way. So when we do this kind of thing in advanced statistics, it's not for love of trouble that we want to calculate strange formulas. They have relevance to real life situations. Even if it is on a hypothetical basis. We had agreed that you should just get ready for R. We will soon get through with the calculations. The last time so here we go. This is what we have been calculating on the whiteboard. It is that simple. That is discrete probability distribution, and we have taken one example. Now, we go to continuous probability distribution. Millie, you suggested we take breaks. We are going to take a break when we are going to do R. Remember last time there was recess. The previous time there was the seminar by our wonderful VC. So we have the time now. Now, we had talked about probability, continuous probability distribution, and the asymptotic quality. Now, there are three kinds of distribution that follow the continuous distribution principle. One is called uniform distribution. We are not going to talk about it for obvious reasons. The other one is exponential distribution. We are not going to talk about it because we are not in economics here or maths or statistics. We are going to talk about normal distribution because it relates to natural events, normal events. And you see, most of the time when you are doing your sample size, we want to know if it is normally distributed and whether it meets the central limit theory. That is why we are focusing on normal distribution. So, under normal distribution, which is always a bell curve, the kind of distribution, the probability is always area under the curve. I am going to show what normal distribution looks like. For example, if in this class of RES 851, we got into a hall and ask everybody to move to the stage and start arranging people by their heights, you'll find that the heights, a lot of people will be within a given range of heights. Then there will be outliers. There will be people who are too short, and there will be people who are too tall in that class. So that is what a normal distribution looks like. For example, in this diagram, let me first define what we call a standard normal distribution. A standard normal distribution is a distribution where the mean is 0, the standard deviation is 1. That is standard normal distribution. The negative side and the positive side are the same. So if you add them together and calculate the difference, the mean is 0. But what is standard deviation? If somebody just asks you, because it's a very common word, standard deviation. Standard deviation between 0 and 1, there you see, that's 1 standard 0 on either side, -1 or +1. So standard deviation, by the fact deviate from what? Deviate from mean. So when we talk about standard deviation, we look at how values, observations are different from mean. So one measure of difference between one value and the mean is called one standard deviation. Two measures are two standard deviations. Three measures are three standard deviation. Now, if you look at the figure before you, a standard normal distribution with the mean 0. The area under the curve, if you look at, if you can follow my cursor, this area, it has 68% of all observations. It is one deviation on the left and right side of 0. That is where most of the data is. For instance, if you take kids in primary 1, or let's say grade 1, children whose ages are 7 years and below, and you take maybe 100 of them, if you weigh them, you will realize that majority of them will be around 20 kgs. Under extreme circumstances, so under normal distribution, 68% of them will be around 20 kgs in weight. So the biggest distribution concentration of ages will be around 20, 68%. Now, if you take a range of between 15 and 20, you will find it comes to 95% of them, 15 and 25. That means you have started including outliers. Between -2 and 1, those are outliers. Between this area and this area, those are outliers. Then extreme outliers, you'll find those that are extremely thin, 10 kgs, which is impossible on the extreme side. And then you find those who are heavy, maybe obese, 40 kgs on this side. So the tapering sides that are towards the 0 lateral line, the x is 0, are extreme outliers. This is what a normal distribution looks like. So every time we talk about standard deviation, just know that it is unit measure from the mean, one unit measure away from the mean, neither left or right side. That's standard deviation. It looks like a bell, as you can see. Now, the formula for finding the function of standard of normal distribution, a function of normal distribution is presented below. I assure you, we cannot have that in exam. We don't want to be statistics teachers here. This one, we're just discussing what a normal sample should look like. A normal sample, because now you're in your research phase, you're going to do sampling. What is a normal sample? How should it look like? So forget about the formula and focus mostly about this figure. This is what a normal sample should look like. Majority of observations should be about the mean. 68% of them. Now, if this is an explanation, a family of normal distribution is differentiated by its mean, mu, and standard deviation, which we've talked about. The highest point of the curve is the mean, the median, and the mode. So you can see the highest point is here. This is the mean, which is 0, the mode, and the median. The mean can be positive or negative. It's symmetrical with the tails of the curve extending to infinity, not touching the horizontal axis. See, these ends, the ones that we call outliers, or the extreme ends, they're extending to infinity. Hypothetically, they're not touching the 0x line, and the zero line on the x-axis. They're saying it is not skewed, and its skewness measure is 0. We are all mathematicians, I think, because whenever somebody is giving an opinion, you'd hear another person saying that his opinion or her opinion is skewed towards the other end. So skewness is there. So it is not skewed in any way. It is symmetrical. The standard deviation determines how flat or wide the curve is. We'll see that. So the probability of normal distribution are given by area under the curve. The total area under the curve is 1. So the left side is 0, the other side is 1. Now, this is what we call skewness. This is a visual representation of skewness. Like the first is positively skewed. Most values are on the right side. The next here, if you see my cursor, is negatively skewed. Most values are on the left side. So when we talk about skewness, look at that guy, remember this figure. Then there's something we call kurtosis. Kurtosis measures how high, thin, or broad the curve is. Like, if you look at the green line on the picture on your left, the green line shows positive kurtosis. Too many values are very close together. That's why it is high. Just like when we were modeling COVID, during the peak, the infections show high. Like when you look at Omicron, too many people affected in one day. So the kurtosis there is very, very high. When you have too many values here, the kurtosis is positive. This one that looks like a hill below is negative. The height of the curve is too low. In this case, the standard deviation is wider, so the curve is a bit flatter. Men are colorblind. I don't know whether this is pink or maroon or something, but the one in the middle is the normal curve. Symmetrical, it's well distributed. Now, when you hear of kurtosis, think of this figure on the left. So this is a bit of explanation. When you look at this figure up here, we are measuring the points at this 68% of the values, 95% and 99.7%. What that means, the explanation is here. 68.3% of values are within plus or minus 1 standard deviation of its mean. If you go back, you see 1 standard deviation is here. On the left, another one is here. So 68.3% of the values are here. That's normal distribution. The other one, 95.4% of the values are within plus or minus 2 standard deviation of its mean. Sorry. C, plus 2 or minus 2 standard deviation of its mean, 95.4% of the values are here. Now, 99.7% of values are within plus or minus 3 standard deviations of its mean. That is up here, yes, 99. It covers 99.7% of the observations. So when you're doing your data, if you enter them and they don't have this kind of normal distribution, you will not achieve reproducible results that are replicable, that could somebody would make a generalization from. Now, standard normal distribution. A random variable that has normal distribution with mean 0 and standard deviation of 1 is said to have a standard normal distribution. We had said that earlier. This is what a standard normal distribution looks like, just like the other one, except now this one we have shaded different regions so that you can see what it looks like. There is a hill in my county that looks like this. I've also seen that such hills might also be in other counties. There's a hill called Asego Hills. It looks like this exactly. It has a bell curve like this. So this is what a standard normal distribution looks like. So we have what we call once people talk about formulas, people get easily scared, especially in mathematics. we always have things that we call Z tables. We have T tables, Z tables, F tables. Z table here is very useful in standard normal distribution. If you calculate, I want to see what we can calculate and find the values. I want to see how we can get use Z tables to in this example. From actual road test with the tires in Kisumu, Onyango Engineering Group estimates the mean number of kilometers the tires will last is U, that's mean, 36,500 kilometers. The standard deviation is 5,000 kilometers. The data collected indicate that normal distribution is a reasonable assumption. What percentage of tires can be expected to last more than 40,000 kilometers? Now, under standard normal distribution, signified by Z, Z is calculated as X, the observation, minus mean. That symbol is not U, it's called mu, over standard deviation. We are asked what percentage of tires are expected to last more than 40,000 kilometers. So here, Z, we don't know. X, we know. 40,000 kilometers. Where we want the tires, we want to know what percentage of tires can last that long. The mean mu we know, which is 36,500. Standard deviation we know, it is 5,000. So can we calculate the percentage of tires that will last 40,000 kilometers? You have a calculator, we're calculating Z. Using the formula, I want you to calculate also and get your answer. Who is done?
0.7.
0.7, yeah.
Okay. Yeah, it is 0.7. Now find it on the Z tables. Now, to get the percentage, you find it on the Z table. So I want to display the Z table. I want to look, we want to Google it online, display it. Z tables. Z table PDF. Are we seeing that Z table?
Yes.
Now, where Z is, there's this column, Z 0.1, 0. Up to 0.7. But we are looking at the Z values going down this way. So our value was 0.7. It is somewhere here. 0.7, you can see it is, the probability there is 0.242. Because we are talking about percentage of tires, we multiply that value by 100 times 100 is 24.2%. Here it is, our 0.7 is here. Suppose we found our Z to be 2. Should have been 0.0222 times 100, should have only be 2%. But our Z was 0.7.
Excuse me, Daktari.
Yes, please.
For the Z values, where are we looking at the negative side on the Z tables?
We have used the one-tailed test. If we were to use the left and the right tail, we come and here. 0.7. It comes to
75.8%.
okay. We agreed that the total area under the curve is always 1, isn't it?
Mm-hmm.
1.
Yeah.
But the value here of the shaded region, you see there, cumulative probability, allied to 7 here is
5.8.
8. Subtract it from 1. What do you get? You have a calculator. It comes to 0.242, isn't it?
Yeah.
If you multiply that by 100, you arrive at the same answer.
Okay.
Yes. So we did not want to I did not want to let you into the nuance of going to subtract 1 from it. I just wanted you to calculate directly and get it. Okay, thank you very, very much. That has helped to understand that you can get direct or subtract 1 from it. Thank you very much for that question. I would have overlooked it. God bless you. Yeah, now that we have handled discrete and continuous distribution. So now we want to go to the most enjoyed part, the most enjoyable part of why we are data analysts. So we are going to do R. Please open your R console. No. Let's take a break for 10 minutes and resume. The R will not take us long. 10 minutes only. Are we back? Are we back here?
Yes, Professor. We are
Yes,
back.
we are.
Okay, thank you very much. Now, let us congratulate Helen for the work she's doing in agriculture. Forgive me, but I happen to like reading. I once read a book, Arusha Declaration by the former president of Tanzania, Mwalimu Julius Nyerere, where he's talking about who pays the debt, who actually pays that foreign debt. It is the farmer. Where is that balance of trade? You realize that from between the farmer and the factory, there are too many brokers who produce nothing. And they make most money. And they live in towns. But the farmer, he lives in the village, in the rural areas. She cultivates the land, tenders the crops until they're ready. Then comes the cooperative brokers who underpay the farmers, they collect and export the produce. So according to Nyerere, in his book, in that Arusha Declaration, that good roads, better roads should be built in rural areas, not in town, where the people who actually pay the debt live. That is what we should do with our farmers. And try to make sure that we get brokers out of the way and get cooperatives well managed without fleecing the farmers. You would get a copy of that book and try to read it. Now, there is data we shared in this class. It was data on health. Can somebody try to recall what was done before? LS, open and close empty bracket. If I type mine, I'll get too many cases. So I am requesting you to open your R console. And type your LS, close and open an empty bracket. You see what you get on your side.
We had data on age, health, and cases, health, age.
Okay. And how about history? History. Open and close an empty bracket. What do you find on your side?
US population.
Good, good, good.
Both women, yeah.
Okay. Now, the last time we learned how to import data into R. We learned how to import data into R. And I want us to do it. Okay.
Mwalimu, I think you have to bear with us. Some of us have typed LS and it's showing error.
What error? How?
Do LS
LS
into brackets
open and
and
close an
close.
empty bracket.
Okay. I think there was a problem. Then it brings the data of age, cases
Yeah.
held.
Yeah.
So you said, then I do history.
Yeah, do history.
Open and close. Okay, yeah. It gives me the history of CSV cases held, blah blah blah. Yeah.
Okay.
Yeah.
So let us call the data we had shared in class.
Daktari, only three.
Yes.
Only
Go
health.
ahead.
I have only health, cases, and activity.
That's fine. Let us import the data we had on health into our R. If you successfully import it, you raise your hand. I guess we did it together last time. I have put the chat box, the codes on the chat box, and we are doing it here. Helen, here we are doing it. So
you're saying we import health?
yes. I've put the codes for importing it. So
Whoa.
Please take us back to the code, if you don't mind.
check the chat box. So I intentionally gave this large data set so that we can use it. So how many of us have imported it?
So it brings a table to choose from.
Yeah, you know where you had stored it in a folder, and I think I gave directions to that.
Okay.
Mwalimu, after I've picked it, but it's not coming.
Call it. Hussein. Yeah. Call it.
I've called it.
You called it.
Yeah, but it's not coming.
The time you are still trying to call.
Oh, you call it. How have you?
Oh, yes.
Remember
found
how you
it.
used to call that woman the other last time? Just after writing the code, which in this case is health.
It's there.
Assignment operator read.csv, open bracket, file.choose, open and close an empty bracket, then close the whole bracket. It comes. So for you to call it, you just enter and type health.
Yeah,
It has come.
You see, very simple. By a show of hands, I want to see those who have successfully called it. And class rep, please share with Madam Helen the data. Thank you, Mapesa, Livingstone, Enrica, Mary, Siham. Aha, wonderful. Madam President, are you here?
Yes, I'm here.
Please share the data with Helen.
All right, thank you.
Okay. So, in this data, we have under 5 mortality, no, under 5 new infections. Okay, what we did when the county governments came into operation, and we wanted to track the uptake of health budget, then we decided to track expenditure on health, especially as far as detection of infectious diseases are concerned. So you can see this was done in, the research was done in 2015. Now, you see the counties here on the first column. Let's see how you can isolate the first column. The first column is county. Let me put county. Okay, we have isolated the county, okay, so that you can see all the counties. What we are doing is called exploratory data analysis. Let me share this chat code how to separate one variable and call it. Here we go. So one variable is county. You can see that we looked at all the counties from Baringo to Vihiga and Wajir. Yes. Now, that is how to separate, how to isolate. For those people working in the laboratory, also there is the issue of culturing and isolating the vector. So after that, we looked at the number of infectious diseases reported per county in that year. And that is where we have under 5 new infections. We can also isolate it. U5. U5, we have talked about county.
Prof, is this bracket 1 or is it a different sign?
Oh, square bracket. Square bracket.
Square bracket, okay.
You know, square bracket, I don't know if you can find it down your keyboard. A square bracket is the one that looks, it doesn't have, not a curly bracket, square bracket. So we looked at under 5. Under 5, new infections. I will put it as, see how we name the codes, the variables, so that you don't, because we are going to use them. You'll be surprised.
I think Mwalimu, I got an error up there on the county.
How many people have got to the county? By show of hands.
We cannot get the square brackets and cannot copy either.
You cannot copy that thing either.
You can't copy what you have. I can't seem to copy what you have pasted on the chat. The count.
County.
Perhaps you can go up a little bit so that we see what you had done on this R.
Okay. After you have typed that code, you call it. Every time you enter and then call it. Call it, just type the name you had used, county. And it is case sensitive. How many people have been in a position to call the county? Ken Williams, wonderful. Kawira, good. John, Mary. We're progressing well. Zara, awesome. This is awesome. So, under 5 new infections, let me also put that in the chat box. It is the second variable. So in the curly brackets, you put 2.
Curly or square?
Yes?
Curly or
Oh,
square?
sorry, square bracket, sorry, square. Then you call it. So how many people have called the under 5 new infections? Good. 7. I want to see more hands. Ellen, if you have difficulty, you let me know.
I seem to
You
get
did not download R. Ellen, are you there? Okay. So we are going to above 5 new infections. A, 5, and I. It is the third variable. So assignment operator, health, square bracket, 3, close the square bracket, enter. Call it A, 5, and I. There it is. How many have done that? The show of hands. It's the third variable. I see 8 people. You will not regret doing this because I'm seeing where we are going. So that is 5. So we have county, we have under 5 new infections, we have above 5 new infections. So let's go to.
Just a question.
Yes. Go ahead, please.
So in terms of how you have abbreviated the data, so I can see that in the data you have the descriptions, full descriptions. Yet when we are calling the data, we are using abbreviations. Is that just your creation, or R will understand that, this is
No.
what it means? And why are we not using capitals, yet the data is coded in capital letters?
First, in coding, you cannot use full names like you see. For example, under 5 new infections, such a mouthful you cannot use. So we have abbreviated when we are isolating the variable to use it elsewhere. So we use a shorter one that we can easily write and easily memorize.
Is that abbreviated somewhere out of the data that you have shared with us? How does R know that this is the abbreviation for this data set?
We have, because we are asking R that, you see, for example, if you say U5NI under 5 new infection, which R does not do, you are coding, you are instructing R. That's why you're putting assignment operator. That's something that looks like greater than and a dash. That's called assignment operator. Then we direct it, we assign it to health. Health is a data set that thing is. Then we put the square bracket and tell him in that bracket is the first variable. That's why we put 1 there. Then we close the bracket and enter. So
now you're speaking, Professor.
There are 2 types of data analysis softwares. One are called command-based. For example, Excel, SPSS You can just click a button, tick, it does. Then there are code-based. You can design your codes, design codes and use them. R is one of them. Python is another. So it is easy to use R. R is very scientific and it's helpful it's free. We are talking about the advantages. It's free, very free, like you see. So I prefer the code-based. So we have looked
Excuse
at...
me, Daktari.
Yes, please, go ahead.
Yes, I have managed to type on the console the U5NI and also the previous one that you have given, but it's just blank. What is the issue in such a
Have
case?
you called it? Just again type.
Yes, I called it. Oh, sorry.
Just call it. If it is U5NI, just enter and write U5NI. After writing the code, you enter.
Okay.
Yes, yes. If you don't enter, nothing will appear. You enter and write U5NI, or if it is the above 5, you enter called A5NI. Now, let us look at the next. The fourth variable here is total new infections. So let us just abbreviate it our own way. The fourth variable is TNI, total new infections, small letters. Okay. TNI is the fourth variable, so we put assignment operator. The data set is called health, and it is the fourth variable. If you enter, then you call it TNI, sorry, TNI. There it is. Total new infections. There it is. So here we have combined the under 5 and the above 5. How many people have done the TNI? Ah, wonderful. 6, 7, 8, 9, 11. Wonderful, wonderful. Continue. 12. Okay. Wonderful, wonderful, wonderful. Zara, how do you find it?
It's really interesting. It's fun to do it.
Wonderful. So now that is the fourth variable. Now let us go to the fifth variable, recurrent expenditure. Let us just call it recurrent expenditure, REC, for recurrent. REC, REC. Assignment operator, health. square bracket, the fifth variable. Then you call it, enter, write REC and enter again. There you have it. So how many people have called the recurrent expenditure? 4, 5, 7, 8. I am waiting until you get to 12. Okay, continue. Karan, how are you?
I'm well, Prof.
Are you enjoying it?
It's fun.
Good. That is how we teach statistics in 21st century. Then
Agreed.
we go to the sixth variable. The sixth variable is development expenditure. Development health expenditure. So let's just write it dev. Assignment operator health, square bracket is the sixth. Then you enter, you close it, close the square bracket, enter, then call it dev, enter, and there you are. How many people have called development expenditure?
Come again, Daktari.
Yes.
Come again, and then kindly explain when you
Yes.
say fifth variable, sixth variable, first variable, where are you getting them from?
From the data set, health, that we shared. You see, we started with the count in the first column.
Yes.
Then under 5, the second column. Those columns are what we call variables here.
Oh, okay.
Yes.
Professor, that is where we should have started, because it's actually easier if you look at the actual data set outside of R, you can see how they are appearing on columns. And if you just count them physically, you can see that you're
Yes.
moving across columns. We are on column number 6.
Wonderful. So you see, thank you, Caroline, because there are things, insights you get on your own. If we have to say everything, sometimes we forget. So we remember how you entered, because this thing is case sensitive. If you don't forget what we are going to do next, you're not in a position to do. So the very last variable here is disease reporting rate, DRR. Let I just put it DRR. DRR, case sensitive, disease reporting rate. This is the seventh. Health, open square bracket, 7, variable 7, and then enter. Then you write DRR and enter again. You get it. Now the second DRR. How many by show of hands? Okay. Now we want to do something interesting. Remember how you have saved them. So
Professor, we are consoled whenever we see you also getting errors in R.
Yes, it's very good to get errors in R. That is how we learn.
That's true. That's so true. At least it doesn't make us feel like we don't know what we are doing. It makes us feel normal.
Yes, it feels very normal to be having errors. We can go further and define them. We have defined, we can. Now, if you look at this this data, they are in different units. We have disease reporting rate in percentages. We have recurrent development expenditure in millions, Kenya shillings. We have recurrent expenditure in millions. Then we have total new infections. Are you seeing that in the total new infections, we have some negative values? Are you seeing it there?
Yes, we are.
Yes, we have some negative values. Now, we can do two things here. Since today we are talking about normalization, we can normalize. Or we can do logarithmic transformation. But if you just decide to normalize.
Prof, what did you say?
We have two options here. One is normalize the data. The formula for normalization is always.
Before you go to the formula, Professor.
Yes.
Why are you thinking about normalization and a logarithmic, that one? Why didn't you think about them from the beginning? Is it because of the error you're seeing, or is it just a continuation of what we were supposed to be doing in class?
No, it is because of the error.
Okay.
Because I thought these units can just run without normalization, without bringing them together to the same level. That is why they are telling me that the levels used are different. Are you seeing drops and used to be level? So when you normalize, you reduce two things. You remove the negatives that we saw, and we also reduce the outlier effect. Remember, we did normalization here. We saw there are some outliers, the extreme values. That is achieved by normalization. The other one is logarithmic transformation, which also reduces the outlier effect and brings them to almost the same level. But I have a principle. When I have a variety of foods to eat, I eat the frog first. You start with the most difficult. You do the one that is most tasking first before you go to those other easier ones, so that you clear away with it. So this forces me to introduce you to something in R. Like, if I type in mine like library, hit apply and enter, it will not give me an error. That's a package used for normalization. You see, you try to use it, it will give you an error. And that should inform what I want us to do next. Let me put this on the chat box. You try to run it. Yeah. So the chat box, hit apply. Try to run it, and I want to tell you why I can run it. You cannot run it. How many people have got error?
Error, there is no package called hitmapply.
There is an error, yeah.
Wonderful, wonderful, wonderful. On the right track. So there is an error because that specific package has not been installed in your R console. In R uses libraries. These are libraries of work of packages people are doing all over the world. In Africa, it is only in South Africa where they're developing new libraries for R, new packages for R. So you have to install that specific package and use it. It is called hitmapply. So how do you install it? If you're in your R package, in your R console, there is in the taskbar somewhere called packages, if you can see it, packages. Let us click packages, okay? When you click with me, this is action learning. We learn by doing. There is set CRAN mirror, select repository, install R packages, and update packages. So what do we do?
Update packages. We are updating packages.
No.
No?
Install
We are
it.
installing packages. Sorry.
Yes. Can you try try to install packages? Just select install packages.
Tasker.
When you install packages, it tells you CRAN mirror. You see a number of countries from Australia to whichever. Are you seeing them?
Yes.
Okay. From USA to United States, UT. Now, that shows there is something we should have done first, okay? Cancel down there. Then go back to install packages. Set CRAN mirror. Set CRAN mirror. You want to use libraries from another country.
Excuse me, Daktari.
Yes.
You said USA. Which one? There are so many options for USA.
Cancel the whole thing. Cancel that part and go back to load packages.
Okay.
Then now set CRAN mirror. CRAN means Comprehensive R Archives Networks. CRAN, Comprehensive R Archives Networks. So here, we want to use which network from whichever country we want. So if you click it, click CRAN mirror, it will give you countries. Australia has 3 from Canberra to Melbourne. Austria has 1, Vienna. Belgium has 1. Brazil has 3 networks. The only country in Africa here is South Africa. Out of solidarity, let us try to use the one for South Africa. Their crown here is Johannesburg. They're in Johannesburg. Select it at the end, towards the end. Out of my involvement in art for a very long time, I prefer the mirrors in developed countries. They move faster.
So why are we sympathizing with South Africa?
They are ours.
Oh, we select South Africa.
Yeah,
Yes.
South Africa. The charity begins at home. So select South Africa and click OK. And there's no error, isn't it?
Yeah.
Yes.
Good, good, good. We start with Africa before we go elsewhere. Then now go back to install packages. Select install packages.
Install packages.
Now a list of packages, libraries comes from A to Z. There are thousands. There are thousands. The last one is called Slide. So it's from A to Z. But as we wanted to install a library called
Heatmapply.
Heatmapply. So look for it there. Just scroll down until where you see H.
I would have easily gone to
Found
L
it.
to search for library.
Yes, H.
Okay.
Heatmapply. I found it. Good. Heatmapply. After it is between Heatwave R and Heatmap Flex. Then you click OK. I know I'd install it here in mine. Let me see.
Mine asks, would you like to use a personal library instead? I say no.
No.
So we select the heat supply.
Have you found it? It will install for quite some time. It will be running.
Unable to install.
Yeah?
Unable to install on my end.
What is it saying?
It's saying unable to install packages.
Okay, go and select, don't deny now, to use personal library.
Okay.
Now use personal, customer, yes, go. Who has
Sorry,
given
I
a
use
position to install?
We allow it to use personal library, did you say?
Try it. If it has not only if it has not worked for you by rejecting.
Yeah, because mine is saying error in installing package library lib path dependencies not applicable. There. So
yeah, so don't use, just use personal. Just select personal. Now, this is the kind of thing that we do in modeling and data analysis. Now you realize why we can sit down all day and feel like you have not sat down.
Just bring back one data set. Okay.
Go back and install package. Now when you are installing, don't select CRAN mirror again, just install direct. Because you had already selected CRAN mirror. So just go direct to install. So go and install Hitmapply. Once it starts running, you raise your hand. I want to see. Irene, wonderful. Great. Muraya. Great. Zara, Irene, this is continue. Generica.
Which sign does it have? Heat?
Yes?
What is the sign?
Hitmapply.
Okay.
Heat, Heatmapply. Wonderful.
Mine has brought so many errors. Let me redo again.
Okay.
Oh my.
Now,
it drums, nothing else.
Yeah?
Drum.
Hitmapply. Hitmapply.
HIT.
What is it?
Heatmapply.
Okay.
Me, Daktari,
Yes.
it's like mine has hanged. It has brought so many things, such that when I even go back to packages, everything is disabled.
Really?
Yeah, it has brought trying URL, CRAN mirror. It has brought so many issues.
No. Just go back to packages and don't select CRAN mirror, just select install packages. Then look for Hitmapply.
That's why I'm saying at the packages, they are all disabled now. Or should I close and open?
They are all disabled. Close and open.
Okay.
Well, I think on mine is still running so many things. Packages, it's still running and
yes, it will run like that. Let it do its running. Why are you worried? And you're on the right track. You should clap for yourself.
But at the end, it's showing there were 13 warnings.
It's okay. Let it just warn whoever it wants, but provided it's running.
Actually, I'm successful.
Okay. Wonderful. Wonderful, Kawira.
Mine is okay. It is running. There are a lot of things moving.
It's running. Let it run.
Yeah, it's running.
How does it make you feel?
It says downloaded binary packages are in something like that.
Yes. Once it completes running, you let me know.
Hitmapply successfully unpacked and MD5 sums checked.
Good.
It's unpacking so many things.
Yeah, let it unpack. That is why it's there.
It is calling the women, don't worry.
Yes. That's why it's there.
In fact, when I opened R today, I found 5 women. I don't know when they came.
Now you have surpassed the Muslim limit, Hussein. You surpassed the Muslim limit.
Yeah, 4. There is an extra one now.
Okay.
Excuse me, Daktari. Mine has finished, but it says some files were not downloaded, but now it's back to the console. Is that okay?
Okay, I'm going to tell you, I have put in chat box
Okay.
a code called library into bracket, it apply, close the bracket. Then you enter.
When you enter, it says, welcome to Apply version 1.5.
Okay, that's good. Okay. So how many people have unpacked and installed? Because we want to go to the next level. I'm 7 only.
So Doctor, when it says downloaded binary packages are in C users, blah, 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 is that, where do I go? There are 41 warnings. Use warnings to see them.
So they're not in that library.
So it's at the very end.
Have you typed library, hit apply? The way I've told you.
At the very end, it's showing there are 41 warnings. Use warnings to see them. But down there, it is downloaded binary packages.
Have you typed the code? Yes, Victoria, that's okay.
I can't see this one.
So, Prof, library heatmap. We type library heatmap.
No, put it in the chat box. Let me put it again. Library hit apply. Library, open the bracket, right? Hit apply, close the bracket.
Mine says welcome to Apply version 1.5.0.
Yeah, you found it. Wonderful. So now we want to start normalizing. We want to start normalizing our data. See, we learned about normal data today.
Downloaded binary package.
Yes, so now we want to normalize. Without taking you through the other terrible formula, now this is how we want to normalize software. So for example, under 5, we can normalize counting because counting are names. We can normalize, the name is real name, but we can normalize under 5 new infections. So now we write it in capital.
Why?
Yeah, because they're case sensitive to separate it from the one we had put before.
Oh, because it's like normalizing here looks like we are creating a new data set from the one that we had previously.
Yes, U5NI, yes, that's right. But if we are through with all normalization, we will stop because next time now we will have to start writing, normalizing, and we will start running the code, the thing that gave us an error. So at the 5 new infection, assignment operator, normalize, just write normalize, when the brackets, normal brackets, under 5 new infections, and enter.
So, Prof, sorry, I think, Prof, I'm stuck. Telling me the downloaded binary package are in, so they're showing where it is, eh? And they were still indicating there were 13 warnings. So I don't know where to pick now from there.
Have you? Have you normalized?
Is the bracket square or the bracket is the normal one?
The bracket is normal one.
Mwalimu, why is yours showing NaNa? Mine is showing figures.
Yours is showing figures.
Yes.
Okay.
How do we normalize? You say do you U5NI?
Let me put you the chat box.
Okay.
It's telling me it could not find the function normalize. Am I using wrong?
It's because
You have not successfully downloaded the package.
Oh.
Okay, I got it.
Hmm.
I think I used small letters and it gave me figures.
So you mean that we should be download if it says normalize, couldn't the function normalize cannot be found, we should download it again.
Yes.
Sad.
The NAN stands for what, Professor?
Yes.
The NAN stands for what?
I'm checking. They didn't find the figures. If you found the figures,
Hey, I found them.
You get the figures when you do it in small capital.
What is which one now is small capital, God of heaven. Okay.
Okay. I think
Why-
I've downloaded it so many times. Let's see, above 5.
I think, Prof, I was doing very well earlier, but now it's complicated. Huh? I cannot move further. These downloads are not working. It's showing me an error. Showing error in library, hit play, my play. There is no package called that.
Okay, I want to see if once everybody else has downloaded the package, we can stop there and continue in the next class.
Prof, I need help. I'm Eva.
Can I also ask?
Yes, please.
My question
Yes.
is, for the ones that have come, your results are the way they are arranged and the way mine are arranged, they are different. What did you do so that you have them the way you have the last time?
The 5 under 5 new infections.
They are
5NI.
47, not in column form, the way they have come now finally, just before the
Okay.
console.
Okay. Can you just call them, just enter and write the name again. Enter and write the name and then enter. You see if it will not come the way these ones have come.
So, Prof, I like the idea that I think some of us are still behind a bit because of different. I think for me, I've not yet because I need to figure out on the Mac why it's not downloading.
Okay.
So, yeah.
So the assignment now we can all have are two. One, try to download that package successfully. Two, normalize all the 7 data sets. Next time we meet, we will be doing multiple linear regression using R. So we have that assignment that we successfully download the package hitmapply and successfully normalize the 6 data sets except the county, because the county is their names. They cannot be normalized, they're just there.
Mwalimu, you said the NaN stands for what?
NA means they do not appear in my set as numericals. There's something I have to do further to make them appear as numericals. How many of you have NA?
Yes, mine has NaN. What should I do to appear as numericals?
Same case.
You also?
Yes, Prof.
Okay. How many people have got figures instead of numericals?
I have figures.
Wonderful, Irene. Okay. Yes, Victoria?
No, I was saying I have gotten the figures, sorry.
Yeah, see, some people have got figures, others have got NaN. So try all the remaining variables and we will compare the results next time.
Prof, I have a question. What does this
Yes.
error, object not found, mean, really? I'm struggling to...
Which object is not found? What are you doing?
I was running the command.
Yes.
And it's
Hitmapply.
Yes.
Then you are supposed to, have you done the library?
Yes.
Library.
So I got stuck at where it said welcome to hitmapply version 1.50.
Then just enter and type library into bracket, hitmapply, close the bracket and enter.
Okay.
Yes.
That worked.
Okay. Now, let us agree on one thing. All those who were not in previous class, when we introduced R, we will help them to install R and import the data we're using and bring them up to speed where we are. We handle our class 2 ways. The first is the theoretical. We do theoretical for 1 hour. Then the next hour is the practical use of software. That's how we should teach quantitative statistics in this era. So you have 2 assignments for those who have been using R. Download the package, hitmapply successfully, and normalize all the variables except county. We will start from there next time.
So, Prof, by normalizing, we will use caps, right?
Yeah, we use caps. We use caps.
Okay.
Yes.
What I was asking is that after the library,
yes.
So what do we call after that?
No, after the library, now you can, when you call the library, it comes, it means now you can use it. That is when you can now start normalize this, and that, because it is that library that gives you the ability to normalize. If you
So,
don't use the library, you won't normalize.
so Mwalimu, we have
every
to.
time you want to, if you want to normalize, if you close your console and you want to normalize, you don't go back and reinstall. No, you just type library, open the bracket, hit apply, close the bracket, and enter. Then you start normalizing. We did normal distribution today. So
Normalize.
yes.
But library. Come up again on the library bit. You type library, hit apply.
Library, open the bracket, hit apply, close the bracket, and enter. That is when now you can normalize that. You can start capital U5NI assignment operator. Normalize, open bracket, U5NI in lowercase letters, and enter. Then you call it, you type again U5NI in capital and enter. You get your results. So
I have a question.
Sorry, Prof. Just UN 5N, is it 5I?
yeah,
Is
it
it
depends on how you assigned the name on your side.
If I look at it differently, I don't know if this is correct. Could I normalize from the original data set? That is by defining health column 2 or 3 instead of what we had worked on before in small letters.
You can start. You can try that one as well.
Okay, thank you.
You see, the great thing about R software or any kind of data analysis software, we learn by getting error. When you get error, you know the pitfalls. Next time I don't do this. Okay?
Thanks, Prof. Finally, it worked.
It worked. Yes, so that's good.
Mwalimu,
also
after,
worked for
after
me.
normalizing, if it still
Yes.
brings the NaN, we still we normalize all of them.
Can you try others and see if it does that?
Yes, I have tried the others and it still brings the NaN.
Yes. But that is also your assignment.
To do what,
You find out
Professor? Because
why.
I also have the NANs.
Yes, we have to find out. That
We
is
have to find.
Yeah, that's why the university is called Institution of Higher Learning, not Institution of Higher Teaching.
Yes, to do all that appertains to this degree.
Yes. So let us start from there next time. I'm really enjoying this class.
Okay.
Yes.
Normalize. Oh my God.